Okay, let's proceed. I continue now. Okay, this is the advantages or the compare and contrast. Okay, to compare or to differentiate between packet switching and circuit switching. Okay, packet switching allows more user to use the network. Okay, not like circuit switching, right? So whenever you are doing your handphone calling, only two parties can communicate, right, between you and your friend. Okay, so packet switching offer better sharing of the bandwidth than circuit switching, right? Okay, because all the devices, all the connection will have a same bandwidth without division, just like a circuit switching. Okay, right? Okay, packet switching is simpler, more efficient, and less costly to implement compared to circuit switching. Okay, but there is also a disadvantage of packet switching. Okay, okay, not suitable for real-time devices. Okay, right? Okay, for instance, whenever you want to do you want to call your friend, right? So normally when you want to call a friend, you will use your handphone, right? Okay, and the handphone is circuit switching. Okay, so it is what we call as real-time services. Okay, means that you can communicate in real time with your friend. But for packet switching, it is not the main objective is not to cater with real-time services lah. Okay. Okay, telephone network for residential access network recalls the access networks can be loosely divided into three categories. When we talk about telephone network, okay, residential access network connect a home into the telco, okay, and then we can also have institutional access networks connect any system to a business education system, just like you connect to the university connection. Okay, and the other one is the mobile access network, connect a mobile end system into the network, right? Okay, so the third one, mobile, is just like your smartphone lah. So residential access network is just like your fixed line phone. Okay, just like your fixed line telephone. Okay, right? Okay, these categories are not hard and fast. Some corporate and system may well use the access network technologies that we describe as a residential access. Okay, don't worry much about this lengthy paragraph. Okay, so we can discover later lah. Okay, and this is the details lah for residential networks and so on. Okay, right? Okay, so whenever you are connecting, okay, so this is what we can imagine for our old days of internet connection. Okay, in old days we have jaring, right, from Malaysia lah. From Malaysia we have old ISP, just like jaring and so on. So in order to connect to internet, okay, you have to dial. Okay, you have to dial jaring first. Okay, so that one in the old days, I'm not sure whether you have experienced it during your days. Okay, so I believe this one is history already. Okay, it is a dinosaur already, a long time ago. Okay, you need a modem. Okay, right? And you need a plain old telephone line system. Okay, so you can see a dial-up line, right? So means that whenever you want to have an internet connection in the old days, okay, you have to call the ISP. You have to call jaring. Okay, for Malaysian, okay, for Malaysian, have you heard about jaring before? Pernah dengar tak jaring? Jaring tu like Unify. Pernah dengar ke?
Pernah.
Pernah kan?
Pernah.
Okay. So itu adalah dinosaur lah. Jaring pun dah tak ada lagi. Right? Ataupun TMNet. All this we have a TMNet. Okay. Then in recent days we are no longer using a dial-up connection. Okay. So the home modem will convert the digital output of the PC into analog format. Why? Okay, you can see that. Okay, in the old days, okay, there will no fiber optics cable connection. Okay, but you can see a telephone line, right? Okay, telephone line in which you can see nearby your roadside, right? Okay, so the telephone line is the data transmission is in the form of analog format, but your PC is in the form of digital format, right? Because your PC only understand electrical signals, therefore you need a modem. Okay, so modem is actually a modulator and demodulator in which the modem will convert from digital signal of your PC whenever you want to send email and so on, the modem will convert into analog signal, and then only can be transmitted through the telephone line, okay, or we call as analog phone line. Okay, a modem in ISP converts the analog signal. Okay, so on the other hand, okay, whenever we want to connect to the ISP, okay, there will be also a modem. Okay, so the modem will convert the analog signal back into digital form. Barulah di connect to jaring, to TM and so on. Okay, so the access network is simply we call as a point-to-point dial-up link. So point-to-point means that you need to make a call from your point of your PC, and the other side of the ISP also there will be a point to receive your call. Okay, so normally they will be using twisted pair phone line lah. Okay, twisted pair phone line. So this is a old technology. Okay, in the old days, in which I believe in your days you are no longer experiencing this type of dial-up connection. Okay, right? Okay, and then whenever the technology improving, okay, so same goes to the rate of data transmission, right? So in the old days, okay, the maximum speed is only about 54 kilobits per second. Okay, right? So this is the what we call as the stated speed, but it is not normally you the user, okay, or the subscriber would never receive or get 56 kilobits per second. So normally the subscriber will have less kilobits per second for rates, transmission rate. Okay, so the the connection during all this, okay, it is a very poor quality. Hold on, I connect the charger first. Okay, right. Let me have eraser. Let me have a pointer again. Okay, right. Okay, whenever the technology is improving from the dial-up, okay, there will be a new technology we call as ISDN technology, right? So ISDN is short form for Integrated Services Digital Network. Okay, from dial-up, okay, the technology evolved becoming a ISDN. Okay, allow all digital transmission of data from end system to ISDN telephone line. Okay, right? And then the technology improving becomes the ADSL. Okay, ADSL is conceptually similar to dial-up modem. It is a new modem technology running over existing twisted pair telephone lines. Okay, but the transmission speed is higher. Okay, the old days is about 56 kilobits per second, but during the ADSL time it can goes until 8 megabits per second kilo, and then it will improving into 8 megabits per second from the ISP router to home and system. Okay, right. Okay, the use of ADSL, okay, allows the user to make ordinary telephone call using the ports channel. Okay, remember the ports that we have learned earlier just now, simultaneously while surfing the web. Okay, if you want to understand this part, okay, during the dial-up technology in the old days, okay, whenever you want to connect to internet, you dial the ISP, right? Okay, so whenever you dial the ISP, the ISP need to pick up your call. Okay, after that they will do a handshake, okay, or they will do then authentication. You need to enter your username and password. Okay, so if the connection is valid, then only you can connect to internet. Unfortunately, during the dial-up year ataupun during the dial-up age, okay, whenever you connect to dial-up internet connection, okay, your home telephone are not able to make a call to a personal recipient, right? Okay, so you have to disconnect internet, then only you can make a call. Okay, so whenever ADSL technology appears, okay, they will allow simultaneous process. You can connect to internet as well as you can make a call to your friend using the normal telephone line. Okay, class, is it clear for the time being? Everybody clear? Please respond, class.
Clear, sir.
Okay, so because this one when we are talking about old technology, maybe difficult for you to imagine, right? Because you are not in that age, right? Okay, this is what internet in the old days lah. Okay, you need to connect to a modem. Then if you want to connect to internet, you have to call the ISP. You have to dial up the ISP. So when you dial up the ISP, your house phone is not able to make a call to anybody until you disconnect the connection to the ISP lah. Okay, right? Okay, and then this is the description for ADSL, ISDN, okay, dial-up modem. Okay, right? Okay, so when the technology advances, they are no longer using the telephone line. Instead, they will use the fiber optics. Okay, just like your Unify or Maxis fiber broadband. Okay, so you are no longer some of your houses, especially the new housing area, you are no longer have a telephone line. Okay, you no longer see a telephone pole, a tiang telephone no longer you can see, right? Okay, because there will be a fiber optics okay, being laid, okay, under the ground. Okay, and the fiber optics is the one that being provided by Unify or the Maxis fiber. Okay, so so the fiber optics connect the cable head end, okay, with the ISP lah. Okay, right? Okay, so this is the in our recent days lah, we are using fiber optic, so we are no longer using the telephone line. Okay, so between the house, okay, there will be a modem lah, in which they will convert lah, okay, or we call as the router, okay, router, okay, or Unify router that will connect to the fiber optic cable which is lay under the ground, okay, and will connect to the fiber node. Fiber node, it is just like switching at the end of your street. Okay, you see a box, right? So whenever there will be a new subscriber, okay, the TMNet personnel or staff, okay, need to switch on the box. Okay, then only the new subscriber can have a connection. Okay, but actually the fiber cables is already being laid into the house, but if they are not subscribing with the Unify, okay, there will be no connection, even though there will be a cable connection, but there will no internet connection, right? So the ISP personnel or TMNet staff, okay, need to switch on at the fiber node. Okay, right, and then the fiber node will be connected to the ISP lah. Okay, and the ISP will be connected to the routers, and they will connect to the international internet community, right? Okay, okay, and then we have the FTTH, fiber to home network, right? Okay, so I think this one you can read lah. So I think I can skip this one. Okay, right? Okay, and after the age of wired connection, nowadays we can have a wireless connection, right? Okay, so I'm not sure about Abdullah. Okay, Abdullah, have you ever discovered about Astro channel, TV channel when you are in Malaysia, Abdullah? You heard about it, Abdullah?
No,
No.
I don't.
Okay, so in Malaysia, okay, we have a TV channels, okay, in which connected to the Astro Broadcasting, okay, Astro Broadcasting, okay. So in the old days, okay, you can see a dish, right? Okay, for Astro subscriber in Malaysia, you can see a dish, right? Okay, right?
Yeah.
Okay, so actually, whenever you want to watch a movie or you want to watch a Astro program, okay, even Al Jazeera maybe, okay, there will be no cable that connect between your house and Astro HQ. Am I right? But instead,
Yes.
there will be a dish, right? There will be a dish. Okay, Malaysian, you know a dish? Astro punya cakra, yang kuali tu. Do you know? Tahu kan? Malaysian?
Tahu.
Tahu. Okay. So actually, this is what we call as satellite connection. Why? Because the dish is actually connected to the satellite on the sky. Okay, satellite on the sky, and how they connect to Astro program. Okay, So actually the Astro HQ, there will be a transmitter like a dish as well. Okay, so whenever you want to watch a movie, you want to watch Al Jazeera, or you want to watch National Geography, okay, there will be no cable that connect between Astro HQ with your house. So it's actually being projected to the sky, projected to the satellite, okay, and the satellite delegates to your house. That is the reason why, okay, whenever you want to watch Astro, you have to pay for the installer to adjust your dish, okay, in which the dish is pointing to the satellite. Okay, so satellite is a wireless connection lah. Okay, so this is the evolution of the data communication lah. From wired, so it will become wireless. Okay, so the satellite is just like your ceiling. It is just bouncing the ball that you throw to the ceiling. Okay, so in other words, satellite is bouncing the program being provided by Astro and bounce to the subscriber, Astro subscriber. Okay, so this is what I call a satellite. So in more advanced technology, okay, instead of you are using a 3G or 4G phone, okay, so whenever you are in Himalaya, okay, there will be no no TMNet, there will be no Maxis, okay, transmitter, right? Okay, so how you want to speak through the phone? So actually you are speaking through the satellite phone, okay, right? Okay, so this is the advancement of the data communication lah. So in Malaysia, we have a satellite we call as MISAT. Okay, one of them adalah MISAT, and we have a lot of satellites in the sky, right? So we can have a wireless data communication. Okay, right? Okay, now we have discovered the early days of media. Okay, now we talk about multiplexing. Okay, okay, multiplexing. Okay, you can see for telephone here, right? So this is one phone. Okay, this is another phone. Okay, this is another phone. Okay, so this is another phone, or the phone also can be a transmitter or a communication device, just like your PC lah, right? Okay, so your phone or your devices is actually, okay, want to transmit through the one line, such as fiber optics and so on. Okay, therefore, okay, from this separate cable or a separate line, it need to be combined. Okay, therefore you can transmit into the high speed link. Okay, so this one we call as, okay, this is one link, high speed link connected to 4 channel. This is channel number 1, channel number 2, channel number 3, and channel number 4. Okay, so what is multiplexing? Okay, multiplexing is a set of techniques that allow simultaneous transmission of multiple signal across one link. Okay, because this will make the communication channel efficient, right? So instead of we are sending into separate line, one line, okay, to the receiver and another line to the another receiver, okay, so we combine all the slow speed connection into one high speed link. Okay, so the device that combine, let me have a eraser first. Right, okay, so I take back the pointer, highlighter maybe again. Okay, right. Okay, so the device that used to combine all the low speed channel into high speed link we call as multiplexer. Write down So MUX is a short form for multiplexer. Okay, right? Okay, it is just like a translator lah. Okay, just like modem. Modem will be a modulation and demodulation, right? To convert from analog signal into digital signal into analog signal modulation, and then demodulation will convert the signal you pass through the telephone line back into digital signal. We call as demodulation. Okay, for multiplexing, okay, whenever you want to send through the high speed link, okay, for low speed channel, okay, need to be combined, right? Okay, so the device that used to combine the 4 low speed channel we call as MUX or multiplexer. Okay, right. So this is your receiver end. Okay, your friend at the other side of the world. whenever they want to pick up the phone, okay, of course you need to send to specific telephone user, right? Okay, so from this one high-speed link, okay, so in order to convert back to analog, you need another device we call as DMUX. Okay, so DMUX is a short form for demultiplexer. Okay, jot down. Multiplex. MUX is for multiplexer and DMUX is a demultiplexer. Okay, so application of multiplexers. Okay, a communication system has both a communication network and transmission system. By using a multiplexer, okay, the efficiency of communication system can be increased by allowing the transmission of data, okay, such as audio and video data from different channel, okay, being transmitted into single high-speed line. Okay, so if you want to make a further readings, you can click to the hyperlink here. What is communication channel and what is the meaning of efficiency of communication system? Okay, right. For telephone network, in telephone network, multiple audio signals are integrated into a single line of transmission with help of multiplexer. This is the one. Okay, from one low speed telephone conversation, okay, right, you can combine multiple channel, okay, and then you can submit through one high speed link. Okay, transmission from computer system to a satellite, a multiplexer used to transmit data signal from computer system to spacecraft. Okay, the same application for multiplexer by using a GSM satellite. Okay, right. Okay, so this is the important part. Okay, multiplexing, okay, can be subdivided into these details lah. Okay. Okay, so multiplexing or multiplexer can be firstly can be divided into either analog multiplexing or digital multiplexing. Okay, for analog multiplexing can be divided to FDM, frequency division multiplexing, or wavelength division multiplexing. And for digital multiplexing can can be categorized into time division multiplexing. Okay, right? So we will have a look about multiplexing afterward. Okay, right. Okay, firstly we'll discover about frequency division multiplexing. Right, it is just a traditional analog phone line. Okay, so FDM is an analog multiplexing technique that combines analog signal. You know that a telephone conversation is analog, right? But you want to transmit through the fiber optics, which is fiber optics in the form of digital, right? Okay. Okay, therefore you need to translate from the slow analog signal and combined by multiplexer and send through the high speed link. Okay, it can be applied when the bandwidth of link is greater than combined bandwidth of the signal to be transmitted. Okay, signal generated by each sending devices modulate different carrier frequency. Okay, so we discover afterward lah. Okay, the modulated signals are then combined into single composite high-speed line. Okay, to be transmitted by the link lah, such as fiber optics and so on. Okay, carrier frequencies are separated by sufficient bandwidth to accommodate the modulated signal. Okay, the bandwidth range are channel through which the various signal travel. Channel can be separated by strips, okay, or can be wrapped lah. Okay, we call as the guard band to prevent signal from overlapping. So afterward, we will look about guard band. Okay, in addition, carrier frequencies must not interfere with original data frequency. So the carrier frequency, okay, just sending the data without changing the content of the analog signal being transmitted. Okay, right. So this is the multiplexer. Okay, so this is the first telephone line, and this is the second telephone line, and this is the third telephone line. So you can see you have the different waveform. Okay, right? Okay, so whenever you three telephone line want to transmit the data in the single high speed link. Okay, so you can see here, okay, the signal is being multiplexed. Okay, so for this type of analog waveform, okay, when they pass through a multiplexer, okay, so you can see here, okay, the combined signal is actually a combination of three. A combined link here is a combination of 3 channel. Okay, so each source generate a signal of a similar or different frequency. Okay, in a multiplexer, the signal modulates different frequency carrier. Okay, the resulting modulated signal are then combined into single composite signal. So you can see the waveform here, right? So this is what we call as composite. Okay, composite means that a combination of different type of analog signal. Okay, and it will be transmitted through the high-speed link. Okay, like I have mentioned earlier, okay, the first part we need a multiplexer mux. Okay, and at the receiving end we need another translator to translate from the high-speed link back into specific carrier frequency. Okay, so on the other hand, okay, the composite signal being transmitted, okay, need to be translated back by a device we call as demultiplexer. Okay, so the demultiplexer will convert back from the composite signal back into analog signal to find their specified recipient. Okay, so the demultiplexer use a series of filters to decompose the multiplex signal into constituent component signals. Okay, individual signals are sent to demodulator, then separate them from their carriers and pass to the output line, just like this. Okay, from the composite signal, okay, it will filter and return back to its original waveform and then send to their intended recipient. So this is the task for demultiplexer. So you can see here, this is the multiplexer to combine, and for the multiplexer is to divide again, okay, to change back into original signal into and then send to intended recipient. Okay, right? Okay, so this is the type of question that can be asked in exam. Okay, assume a voice channel occupies a bandwidth for 4 kilohertz. We need to combine 3 voice channel into a link with a bandwidth of 12 kilohertz from 20 to 32 kilohertz. Show the configuration using the frequency domain without the use of guard band. Okay, so I should answer, right? So this is how. Okay, so assume a voice channel. Okay, every voice channel, okay, the size is 4 kilohertz. So this is the bandwidth. Okay, the size is 4 kilohertz, right? From 0 to 4. Okay, we need to combine these 3 voice channel into a link with a bandwidth of 12 kilohertz. Okay, right. So whenever we connect to the high speed channel, okay, so from the 4, okay, we combine into a multiplexer. Okay, so the multiplexer will combine. So if you minus 34 divide by 20, you will get 4, right? Okay, right? Okay, so this is the channel. Okay, right? Okay, so the following channel will occupy the following bandwidth, which is from 24 until 28. So consists of 4 kilohertz. Okay, and the other channel also 4 kilohertz. Therefore, it should accommodate the bandwidth of 28 until 32. Then when it combines all these 3 channel, so it will be transmitted through one very high speed link, right? So this is how to answer this type of question. So as you can see here, let me change the pointer. So we have a blue color. Sorry, pointer option pen. Okay, okay. As you can see here, okay. Between the first channel and the second channel, there will be no separator. Okay, right? Okay. In the following example, we can see an example in which in every channel, okay, there will be a separator we call as a guard band. Okay, so the guard band will protect, okay, protect from one channel bandwidth to the other channel bandwidth. So for the time being, without guard bands, right? So now I'll show with a guard band. Okay. Okay. The question is, a 5-channel, each with 100 kilohertz bandwidth, are to be multiplexed together. What is the minimum bandwidth of link if there is a need for a guard band of 4 kilohertz between the channel to prevent interference? The interference means that we don't want to have a mix up of transmission. Okay, right? So the answer as follows. Okay, right? Okay, so let's say we know that every channel consists of 100 kilohertz. Like this, only 4, right? Okay, the following example, the size is 100 kilohertz. Okay, 100 kilohertz, and yeah, this one also 100 kilohertz. Okay, and this one is also 100 kilohertz, the size. Okay, but in between, we put a guard band. Okay, we put a guard band. Okay, so this guard band will separate between one transmission and to another transmission, and the size of this guard band is 10 kilohertz, right? Okay, so therefore in between, okay, this is the diagram. Okay, the size of one channel is 100 kilohertz. Okay, and the guard band that separates between one channel to the other channel, the size is 10 kilohertz. So can you see here? There will be a gap, right? Okay, so the size of the gap, or we call as the guard band, is 10 kilohertz. Okay, right. So the question is asking what is the minimum bandwidth of the link if there is a need for a guard band of 10 kilohertz, right? So therefore you have to add up all the bandwidth of the channel as well as the guard band, right? So you can see here we have 4 channels in which the size of one channel is 100 kilohertz. So we have 5, sorry. We have 5 channel, 1, 2, 3, 4, 5. Okay, when 100 kilohertz times with 5, we'll get 500, right? And in between, we have a guard band of 10 kilohertz. So we have to add 10 kilohertz of guard band for each of the channel. Okay, so it is equivalent to 500 kilohertz plus with 4 to separate between each channel. Okay, for guard band times with 10 kilohertz, the size for each guard band. So the size of the bandwidth for the link is 540 kilohertz. Okay, class, please digest for a while in half a minute or 1 minute before we go on to the following slide. Okay, class. Understood? Do you get it, class? How to tackle or how to answer this question? Are you clear?
Yes, insyaAllah.
Nadira? Okay, clear? Nadira ada?
InsyaAllah ada.
Okay, Nadira. Right. So this is the way how to answer the question. So don't worry much. The schema or the how to solve this problem is already being included in your slide. Right. So this is the analog carrier signal. Okay. So I change back to a highlighter. Okay. Right. Okay. So we have a 12 voice channel. Okay. So we have the first voice channel. Okay. The second voice channel until the 12th voice channel. Okay. And the bandwidth for each voice channel is 4 kilohertz. I change back to the yellow color lah. Point option in color, take yellow. Okay. The size of each channel is 4 kilohertz. Okay, right? Okay, and when they want to combine into frequency division multiplexer, okay, so it is equivalent to 4 times with 12 lah. Okay, right. So class, what is 4 times with 12? Berapa dapat? 4 kilohertz times with 12 channel. What is the total kilohertz bandwidth? Berapa? 4 times with 12? 48. So there is a reason why you have 48 kilohertz. Okay, so this one line is the bandwidth is 48 kilohertz, in which they are able to send 12 voice channel. Okay, right? So from individual to 12 voice channel, okay, so this is what we call as one group. Okay, this is what we call as one group. Okay, one group. Okay, okay, so let's say we have 5 groups. Okay, we have 5 groups. Okay, what do you think the total bandwidth here, which is combined by this FDM? What is total bandwidth in kilohertz? 5 times with 48, right? So this one group, I have to change back to pointer. Pen. Okay, so this one is one for the one link, one group, the size is 48 kilohertz. Okay, 48 kilohertz, right? Okay, so this is also 48 kilohertz. This is also 48. Okay, and finally the fifth group is 48. So when combined with the FDM, with the multiplexer, okay, what is the total bandwidth class? Berapa? 48 plus 48 plus 48 plus 48 plus 48. Or in other words, 48 kilohertz times with 5 groups, right? You get it, class? Get it?
Yes, sir.
Okay, right? That's the, okay, try to use a calculator. What is 48 times with 5? What do you get?
240.
240, very good. Siapa yang jawab tu bagi bonus mark? Siapa?
Nadira.
Nadira, excellent Nadira. So that's the reason why you have a 640 kilohertz. Okay, consists of 16 voice channel. Okay, from this 12 you times with 5. Okay, right? Okay, and okay, for the first multiplexer we call as group, right? So when you combine all the groups, this is what we call as super group. Boleh? Get it? Get it, class? From a single voice channel, and then when we convert 12 voice channels, so it will be one group. Okay, so we have about 5 groups. Okay, so if the 5 groups combine together, so we'll have a super group. Jelas? Siapa ada dalam ni?
Jelas ya.
Okay je lah. Kalau jelas kita bersambung lah, tak payah tanya lah. Okay, right? Okay. So for one super group, the size is 240 kilohertz. Okay, and the following one we have 10 super group. Okay, 10 super group. So what is the total bandwidth for this multiplexer for following a high speed link? What is the total bandwidth for 10 super group?
2400.
2.52 megahertz, right? Which is 10 times with 240 kilohertz. Okay, in which equivalent to 600 voice channel. Very good. Okay, then this one we call as master group. Okay, and we have master group in which the size is 2.52 megahertz for one master group link. Okay, high speed link. Then we have a 6 master group. Then we times with 6. Then we'll get 16.986 megahertz, or equivalent to 3,600 voice channel. Okay, so from single channel, we combine becomes a group. When we combine group become a super group. When combine super group become master group, and finally it will become jumbo group. Okay, so we proceed to following slide. Okay, so the other types of multiplexing techniques is wavelength digital multiplexing. Okay, so this is the symbol for lambda. Okay, so wavelength digital multiplexing, or WDM, is analog multiplexing techniques to combine optical signal. Okay, usually used in fiber optics, right? Okay, so when you combine a single channel, so it becomes I1, I2, and I3. Okay, and finally, and at the other hand, or at the other side of the link, okay, we need another demultiplexer. Demultiplexer will need to break it up back into their specific channel. Okay, and WDM is used for fiber optics. So you can see here what we have discovered earlier. Okay, okay, multiplexing for analog, we can consist of FDM and WDM, frequency division multiplexing and wavelength division multiplexing. Okay, so this is the concept of a WDM is in the form of prism lah. Okay, prism is just like your kanta lah. Okay, kanta we can have multiple lights. Okay, so when you pass through what is kanta in English? Not sure about it. Forgotten about it. Magnifier, right? Okay, when you use a magnifier, let's say on a sunny day, okay, you can see that. Okay, if you feel the sun, okay, it doesn't feels like you are burning, right? But if you have a magnifier and you put your hand under the magnifier, you can feel the heat, right? And if you magnify into a paper, you can see the paper is burning, right? So this is the concept of prism in wavelength division multiplexing. Okay, and for the final part, in which it is for the digital multiplexing, we have a time division multiplexing. Oh, terlajak, sorry. Okay. Okay, yeah, for the last part, which is the time division multiplexing, is used for digital multiplexing lah. Okay, right? Okay, so this is time division multiplexing. Okay, TDM is a digital process that allows several connections to share a high bandwidth of link. Okay, instead of sharing a portion of the bandwidth as in FDM, time is shared. Okay, you remember the word time is shared. Okay, each connection occupies a portion of time in the link. Okay, we can divide time division multiplexing into two different schemes. Okay, either synchronous or statistical. For this course, we only focus on synchronous time division multiplexing. Okay, so you can have a look first about time division multiplexing. Okay, so it will be transferred in the form of digital signal. Okay, so as the previous example, we use a telephone, right? Okay, telephone is an analog signal, but for time division multiplexing, we use a PC. Why? Because PC is using a digital signal. Okay, right? So we have a look about the first example of time division multiplexing afterward. Okay, right? Okay, so this is the synchronous time division multiplexing. Okay, in synchronous TDM, a round of data units for each input connection is collected into a frame. Okay, so when you talk about digital transmission, okay, you will heard a lot about frame. Okay, we'll learn a lot about frame. Okay, right? Okay, as you can see here, okay, the first channel, okay, consists of A1, A2, and A3. Okay, but it is not being sent in sequence like A1, A first, and then B first, and then C. Sorry, A first, and then follow with B, and then follow with C. But instead, they will be transmitted. Okay, so I take an highlighter first. Okay, so it will transmitted, okay, within the same time frame. Okay, it is not being sent A first, follow with B, follow with C, but it will send all the three channel based on their time frame. Okay, right? Okay, so this is the first example. So have a look to the first frame. Okay, so this is the third frame. Okay, the first frame is the one that near to the multiplexer. Okay, so let me clear the line first. Then we have a highlighter again. Okay, right? So in accordance to the sequence, okay, we'll start sending the one close to multiplexer first. As you can see here, this is our main focus lah. Okay, right? Okay, so this is the first time frame. Okay, consists of A1, B1, and C1. Okay, so whenever we want to submit send a data, it is not being sent A first, compare with then follow with B, and then follow with C, but it will send all the three channels within the same time frame. So you can see here for frame number 1 consists of A1, okay, and then B1 and C1. So the frame 1 will be transmitted first. Okay, can you see, class? Can you understand? Nampak? Can you see?
Yep, sir.
Okay. Then you try to figure out what is the following frame. Cuba tutup mata and just have a look to the left side. Just have a look to the left side, this part. Okay. So the frame which is actually just like a set. Okay. A set that encapsulate your channel. Okay. So as you can see here, for time frame number 2, it will send A2, B2 and C2. So you can see here, the frame 2 is A2, B2 and C2. So can you see here, it is not being transmitted the every single channel in sequence, but it will send in the form of time frame. So this is the reason why we call as time division multiplexing. Okay, so each frame is a 3 time slot. So this is the first time slot, this is second time slot, and then this is the third time slot. Okay, right? So each time slot is equivalent to t divided by 3. Okay, so every time slot okay, this one is equivalent to t divided by 3 lah, because the rest of this frame, okay, the duration is t. If you want to have the each time slot duration, so t need to divide by 3. Okay, class. Is it clear?
Clear.
Continue. Okay. Okay, the other one is interleaving. Okay. Okay. Right. So the TDM can be visualized as two fast rotating switch. One of the multiplexing side and the other is the demultiplexing side lah, as usual lah. The first part is the multiplexer and the other one is the demultiplexer. Okay. Okay, the switches are synchronized and rotate at the same speed but opposite direction. You can see here. Same speed but opposite direction. This one is anti-clockwise and this is clockwise. Okay. Okay, the switches are synchronized and rotate. Okay. On the multiplexing side, as the switch open, the front of this connection, the connection has the opportunity to send unit onto the path. Okay, this is what we call as interleaving. So to cut it short, as you can see here, okay, right? So this is the first frame. Okay, sorry, the first T, the first time frame, and this is the second time frame, and this is the third time frame. So whenever you want to send a data, it's in the form of frame, right? Okay, so for the first period or first T, it will transmit A1 and C1. So you can see here A1 and C1. What about the following one? A2 and B2, right? A2 and B2. Okay, and then the third one will be A3, B3 and C3. So whenever it passes through the high-speed link, okay, on the other side of the world, there will be a demultiplexer in which the demultiplexer will perform the interleaving. The interleaving means that it will distribute back in accordance to the sequence. So you can see here A3 is, sorry, A3 is here, okay, and then A2 is here, back into their sequence. So this is what we call as interleaving. Okay, move on to the following slide. Okay, 4 channels are multiplexed using time division multiplexing. Each channel send 100 megabits per second and we multiplex 1 byte per channel. Show the frame traveling on the link and size of the frame in bytes or bits, the frame rate per second and duration of frame rate in 1 second. Okay, so this is how to tackle this type of question. Okay, 4 channels are multiplexed. So this is the question. So in order for you to easily tackle this question, okay, you need to draw a diagram. Okay, right? 4 channels. 4 channels means that we have 4 channels. 1, 2, 3, and 4. Okay. Okay, each channel sends 100 kilobytes. Sorry, 100 bytes per second, and we multiplex 1 bytes per channel. Okay, we multiplex 1 byte per channel. Show the frame traveling on the link, the size of the frame in bit, byte, or bit, and the frame rate, frame per second, and duration of frame in 1 frame, and the bit rate for the link in bit per second. Right. So for every chunk, for every chunk of the channel, okay, like this one. Okay, the size is 1 byte. So I think I use the pointer pen. Okay, the size is 1 byte. Okay, so divided into 1 byte. Okay, and this one is also 1 byte. Okay, therefore, what is the total size for this one frame class? What is the size?
4 bytes.
4 bytes. Very good. Right? Okay, 4 bytes. Okay, you know that 1 byte okay, is equivalent to how many bits? Class?
32 bits.
8 bit. Okay, jawapan yang betul adalah 8 bit. 8 bits. Right? So 1 byte is equivalent to 8 bits. Right? Jadi kalau kita ada 4 bytes, so 4 times with 8 lah. Okay? And we have the size of one frame is equivalent to 32 bits. Okay, or equivalent to 4 bytes. And we are sending it in 100 frame per second. Okay, and duration for each frame, okay, duration for each frame, okay, is equivalent to 1 second. Okay, sorry, 1 second divided by 100 frames. Okay, so you'll get the duration for the frame duration. Okay, so what is 1 divided by 100 class? Try use your calculator. 0. What is 1 divided by 100 class?
0.001.
0.01 or 0.001?
001.
The rest agree with the answer? Or just
0.01.
0.001? Confirm?
01.
Correct. So the correct answer is 0.01, right? Okay, so this is equivalent to, for each frame, okay, the duration is equivalent to 0.01 second. Okay, the duration for each frame is equivalent to 0.01 second. Are you clear, class?
Sir, can I ask?
Okay. Yes.
Why is the 100 frames tu? Kenapa 100 frames I don't understand about why the 100 frames.
Okay. So regarding the 100 frames, okay, I will explain to you later. Boleh?
Okay, boleh.
Okay, this one I will explain to you later because it is much more complex. Okay, so I just I just illustrate to you the simple part first. Okay, so regarding the 100 frames, I will explain to you later lah. Boleh?
Boleh.
Okay, right. Okay, we go to the following example. Okay, a multiplexer combines 400 100 kilobits per second. Okay, this one as well. Okay, this one as well we will discover later lah. Okay, because this one is also a little bit complex. Okay, jadi this part I can explain during our face-to-face session lah. Okay, to illustrate in better view lah. Okay, right? We skip this one first. This one also empty slot. Okay, synchronous TDM is not as efficient as it could be. Okay, right? Yeah, if a source does not have data to send, the corresponding slot of the output frame is empty, just like this lah. If there will be nothing to be transmitted, so the slot will be empty and it's not effective lah, not efficient. Okay, so this is the synchronization of bits. Okay, right? So every frame, okay, we may put a synchronization pattern, okay, such as this one, 1, 0, and 1. Okay, right? Okay, for detailed example, same as well. I may explain during our face-to-face session. Okay, right? Sometimes some of the content little bit complex to be described in online session. Jadi whenever there will be an opportunity, especially in the face-to-face session, maybe we can discuss further. Okay. So we have about, I think about 10 or 20 more slides, if I'm not mistaken. Okay. So we continue with our following slide. Okay, the following slide is the media. Okay, like I have mentioned earlier. What is the pointer? Pen. Okay. Okay, the the media basically can be divided into two lah. Some, whether it is a wired. Okay, wired. Okay, what is the other one? The contra for wired class.
Wireless.
Wireless, very good. Okay, wireless. Okay, right. So wired. Okay, so we call it also as a guided media. Okay, guided media, because it is being, the transmission is being guided by the cable. Okay, right. Okay, in contrast, wireless we call as unguided. Okay, okay, unguided, just like your 3G or 4G, right? You cannot see where is the direction of your telephone line connection, or just like your Wi-Fi, right? You cannot see where is the direction of your Wi-Fi connection. So that is the reason why, okay, we call wireless as unguided. So please take note on this. Okay, right? Okay, so I change the highlighter again. Okay, okay, the signal are transmitted in the form of electromagnetic energy. Okay, right? Okay, example, radio wave, infrared, visible light, UV light, and cosmic ray. Okay, so all this we call as the wireless or unguided. Okay, each constitutes a portion of electromagnetic spectrum. Okay, right? So on the other hand, okay, this is what we call as guided media. Okay, okay, we have a physical connection and so on, right? Okay, so network media, okay, basically we can subdivide it into three types, like I mentioned just now: conducted, or guided, or wired, okay, or wireless, and the other one is fiber optic. Okay, right? We discover the first one. Okay, conducted media, or we call as wired lah. We call as a wired. Okay, right. Okay, wired. Okay, the common one is the one that you use for your network cable, right? Network cable. Okay, network cable. Okay, okay. Now network cable also equal as UTP, right? Okay, you have heard about UTP, betul tak, guys? Is it true? UTP cable?
Yes,
For
sir.
your network cable?
Yep.
Right, right. So TP is actually short form for twisted pair. Okay, twisted pair cable. Okay, means that, okay, you can see your network cable, right? The white color, right? Okay, so the white color is actually the insulator. It is not a conductor. Okay, so whenever we have time, okay, I will go through with you how to set up Ethernet cable, right? So firstly, you need to strip, or you need to remove the insulator. So when you remove the insulator, okay, I can use the illustration. I use a pen, okay, right? Okay, so you can see a cable, okay, right? Okay, whenever you remove the insulator, so the white color one you call as insulator, insulator, or in Malay you call as penebat lah, insulator, right? Okay, when you remove, you cut using a scissors or whatsoever. Okay, right? When you remove the insulator, okay, so you are not cutting the cable direct, but you just remove the insulator. So actually there will be 8 core inside, 8 core or 8 wires lah inside. There will be 8 wires, and every wires, okay, actually whenever you open it, it is in the form of twisted pair. It will twist in pair. Okay, so if we have 8 wires, okay, then the wires is twisted in pair, means that every 2 wire will be twisted, so we'll have about 4 twists of cable, or 8 core. So this is what we call as 8 core okay, or 8 wires, or 8 wire. Okay, so this is what we call as a twisted pair cable lah. Okay, right? So the one that you use is what we call as UTP, or short form for unshielded twisted pair. Okay, why is it unshielded? Because whenever you remove the insulator, you wouldn't see a shield. Okay, you straight away see the core. Okay, later on during the face-to-face session, maybe I can show you lah. Okay, right? So the other one is a coaxial cable. Coaxial cable is just like your uh, your astro cable. Okay, right? Okay, so this is what we call as conducted media. Conducted media means that you can see a cable. Okay, so conducted cable can be in the form of twisted pair or coaxial cable. Okay, so remember I illustrated to you just now. Okay, twisted pair cable, UTP cable. So whenever you remove this part, okay, you cut this part. Okay, you remove this part. Okay, you remove the insulator. Okay, you will see the 8 core. Okay, and whenever you remove the insulator, you can see it's in the form of twisted in pair. So we have 1 core, 2 core, 3 core, or 3 cable, 4 cable, 5 cable, 6 cable, 7 cable, and 8 cable, right? So every 2 cable is being twisted. That's the reason why we call as twisted pair cable. Okay, consists of 2 conductors, coppers, insulated and twisted together. Okay, right, a carry signal to the receiver, a ground reference. Okay, the data rate can be achieved depends on the thickness of the wire and distance between transmitter and receiver. Okay, it means that if you are creating your network cable very long, okay, if you are creating your cable very long, maybe about 50 meters, okay, you can see your connection is not good. Why? Because whenever the distance increase, okay, there will be data loss. Okay, the shorter will be the better for the data transmission. Okay, data rates can be achieved depends on thickness and distance. Okay, possible problem interference. Okay, let's say your Ethernet cable you lay nearby your electric cable, your adapter and so on. Okay, then your data will be disrupted a bit. Okay, because okay, every electrical cable, okay, will have a noise that they will penetrate, okay, the other Ethernet cable. Okay, right? So this is what we call interference or noise, or crosstalk. Okay, the number of twisted per unit length determines the quality of the cable. Okay, right. Okay, so the one that you are commonly used at your office or your PC, we call as unshielded twisted pair. Why? Whenever you remove the insulator, there will be no shield. Okay, right? So the other types of cable we call as shielded twisted pair. Okay, shielded twisted pair, whenever you remove the insulator, there will be another metal shield, okay, that will protect the core inside. Okay, UTP is the common use compared to STP lah. Okay, normally we use UTP, unshielded twisted pair. EIA classifies twisted pair into 6 categories, which are determined by cable quality for specific users. Okay, right? Okay, remember I told you your UTP cable, or you call as Ethernet cable. Okay, Ethernet cable. Okay, okay. Okay, have you heard about Cat5 class? Have you heard about Cat5 cable?
Yep.
Kan. And some of you, for the latest technology, we use Cat6, Cat7, and so on, right? Okay, right? Some I use Cat6, right? So Cat is for the category, right? So this is to differentiate the quality of the cable, right? Okay, so we seldom use Cat1, Cat2, Cat3, Cat4. Normally, at least we use Cat6, right? So the category, Cat is not for kucing, not for meow. Okay, it is for category, short form for category. So that's what we call as cat. Okay, right? Okay, so the later cat, such as cat 5, will have greater bandwidth, right? You can see for cat 2, less than 2 megahertz, right? For cat 5, we can go until 100 megahertz. And the data rate, we can go until 100 megabits per second. Okay, right? One more for cat 6, we can go until 1000 megahertz, and we can go until the extent of 1000 megabits per second. That is the reason why if your office is changing from cat 5 to cat 6, you can see your internet connection will be much more faster. Okay, right? Okay, so this is the twisted pair performance. Okay, right? Measured by comparing attenuation versus frequency and distance. Means that the greater distance, okay, there will be more data loss. Okay, and the gauge, okay, is the measure of thickness. Okay, the measure of thickness of the wire lah. Okay, so that's the reason why for those that are familiar with electrical cabling, so you will heard about the word gauge. Gauge is identifying the size of the cable. For gauge 18, the size is about 0.043 inches. Okay, right? For for gauge 26, the diameter of the cable is about 0.0159. So if the gauge is thicker, okay, the transmission of data will be better. Okay, right? Okay, so previously we learned about shielded twisted pair or twisted pair cable. Now we learn about coaxial cable. Okay, coaxial cable is just like your astro cable. Okay, astro cable that you connect to your astro receiver lah. Okay, a coaxial cable carries signals at higher frequency range than twisted pair. Okay, the structure is protected against noise. Okay, categorized by radio government or RG ratings, which denotes the unique set of physical specification. Wire gauge and inner conductor thickness and type of inner or inner insulator, the construction of shield, and the size type of outer casing, right? So you can see here, okay, for coaxial cable, there will be a lot of insulator and they will have a lot of protector. Okay, so we have a outer plastic cover, and then we have insulator, okay, and then we have a outer conductor shield, and finally, okay, the most inner part, which is the inner conductor. Okay, so this is the coaxial cable, right? Okay, so for coaxial cable, we are not using a CAT, but using RG, radio government. So you can have RG59, RG58, and RG11. Okay, right? So RG59 is used for cable TV, RG58 used for thin Ethernet, and RG11 is used for thick Ethernet. Okay. Okay, this is the cable performance. Same, measured by comparison of attenuation. Attenuation means that data loss lah. Okay, versus frequency and distance. Okay, attenuation is much higher in coaxial than twisted pair. Reason have a much higher bandwidth. Therefore, signal weaken rapidly and needs the frequency use repeaters, right? Okay, so whenever, okay, you can imagine a signal, right? Okay, the signal at the starting end, the signal is very powerful, very strong. But whenever it travels in far distance, the signal becomes weaker and weaker. Okay, so in order for us to strengthen the signal, we need a device we call as repeater. Okay, we need a repeater. Okay, so the repeater is actually will energize, or it will make the signal back to its maximum peak, right? So you can see here, whenever the distance increasing, okay, the signal strength will becomes weaker and weaker. So whenever we pass through a repeater, okay, the signal will become strength again. Okay, so this is what we call as repeater. Okay, right? Okay, so this is the fiber optics, the nature. Okay, fiber optics will be transform or transfer the data in the speed of light. Okay, okay, straight line travels through a single uniform substance, right? Okay, so you can see here for fiber optics, okay, it is just like a glass, okay, so there will be a cladding to protect the core, okay, or the glass, okay, so actually the signal is being reflected through the core from sender to receiver, right? Okay, for multiplex for fiber optics, okay, we have several propagation time, whether it is we call as the mode lah, okay, okay. So multi-mode refer to multiple beams from a light source move through the core in different paths. Okay, the mode can be subdivided either to multi-mode or single mode. Okay, and multi-mode can be further classified into step index or graded index. Okay, okay, and as for the modes, this one it is not that important, we can discuss later lah. Okay, okay, and this is the physical looks of a fiber optics cable. Okay, okay, fiber optics cable, okay, the inner part is the core. Okay, either it is a glass or a plastic core, right? Okay, therefore, okay, for a fiber optics cable, please avoid to bend, to make a force bending the cable, because the glass might break. Okay, right? Okay, okay, so like UTP cables, this is your UTP cable, consists of 8 core, right? Okay, and the 8 core, you will connect through a connector, right? Remember, we have a connector that connect to back of your PC, right? Okay, so this is the UTP. Okay, and this is the connector we call as RJ45, registered jack 45. Okay, so whenever later you learn about cabling, okay, I will give you a cable and I will give you RJ45. Then you need to slot in the RJ45 connector into UTP cables. Okay, but if you didn't do anything, okay, the RJ45 can easily um, taken out or loose from the cable, right? But if you refer to your Ethernet cable, it is quite tight, right? You are not able to pull the transparent connector, right? Why? Because you need to clamp. You need to press something like alligator clip lah, okay, to make it apa ni, to make it attached to the UTP cable, right? But for fiber optics cable, okay, you are not doing that. You are not clamping the connector with the fiber optics because it will break. Instead, you will use a device we call as splicer. Okay, splicer to splice. Okay, splice means that you use something like melting to melt the glass to connect between the cable. Okay, so this one can be described later lah. Okay, right, so anyhow, this is the architecture for fiber optics cable. We have outer jack, okay, and then we have DuPont Kevlar. So the reason for DuPont Kevlar, this is to protect the glass from break. Okay, so it is to strengthen the cable. Then we have plastic buffer, and the inner part we have the glass or plastic core. Okay, right. And for fiber optic cable, we can identify by different types lah. 50:1:5, okay, or 62.5 over 1:5, and so on, right? Okay, so 50 is for the core, okay, and 1:5 is for the cladding, okay, and this is the mode lah that we have gone through very brief just now, okay, right? Okay, for cable 50:1:5 is used for multi-mode graded index. Okay, cable 62.5 over 1:5 is used for multi-mode graded index as well. Okay, but for 7 over 1:5 is used for single mode. Okay, so this is detailed description for fiber optics. I think we can skip this one. Okay, right. Then we move on to the unguided media. Remember I mentioned to you about unguided media, right? Okay, because the transmission of data is not guided by any cable, can be in any direction. Okay, so for wireless communication, it refers to unguided media. Okay, so in wireless, actually we are broadcasting our message or our data through the air. Remember, whenever you want to use your remote control, your TV remote control, okay, so what is the type of wireless media that you use for remote control? From the
Infrared.
word, correct, infrared, right? It is infrared. Okay, so the infrared, okay, do you see any cable? No, right? You're just pointing to the air, and you have to make sure that you are pointing direct to your TV, right? Okay, so this is what we call as broadcast through the air. Okay, so this is what we call as line of sight. Okay, line of sight. You can copy this one. Line of sight. Okay, line of sight means that your remote control, okay, must in one line with your receiver of your TV, right? But if you put your hand in between the remote control, okay, in which you are pointing your remote control to your hand, again, it will block the signal towards the television, so there will be no line of sight. Okay, so this is what we call as the line of sight. Okay, right, and the wireless media, normally we refer as a radio wave and microwave. Okay, so this is the frequency. Okay, so this is what we call as the frequency lah. Okay, just like you are adjusting your radio channel, right? For music FM, for classic FM, okay, or for Sinar FM, right? So you can see that the frequency is different, right? Because every radio channel have their own frequency. Okay, so the frequency, okay, for radio wave and microwave is between 3 kilohertz until 300 gigahertz. Okay, and for in between 300 until 400 terahertz, okay, is for infrared. And the following one will be for light wave. Okay, types of wireless media. Okay, wireless media basically can be subdivided into three, whether radio wave, microwave, or infrared. Okay, so the radio wave is just like your pemancar telco. Okay, your telco transmitter, right? So let's say you are in or just like your pemancar phone transmitter, or just like your radio transmitter. Okay, let's say you are far away from the transmitter. Let's say you are in the middle of jungle. Okay, you can see that, okay, your signal is weak. You are not able to hear the radio channel, or you have difficulties to make a call, right? Okay, because your distance is far away from the transmitter. Okay, so characteristics is omnidirectional. Okay, sender and receiver do not have to be aligned. Okay, it is a sky propagation. It is transmitted through the air. Okay, and it can penetrate wall. Is it true? Can you hear radio even though you are in your room? Okay, you know that pemancar is outside, the transmitter is outside your house, right? So there will be a wall that block between your radio with the transmitter, right? So radio wave can penetrate the wall. Okay, application using normally used in multi broadcasting lah. Okay, broadcasting means that the radio channel will transmit the radio signal, and you can only receive without giving any feedback. Okay, such as AM and FM radio. Okay, so for microwave, it is unidirectional. Sender and receiver need to align to interference line of sight, cannot penetrate wall using dish antenna or horn antenna. Okay, right. if you want to imagine about microwave, okay, maybe some of you have seen there is something like astro dish at a petrol station, right? Okay, at the petrol station, such as Shell, there will be something like a dish. Okay, so this dish is actually transmitted the signal through the HQ. Okay, so this is what we call as the microwave lah. Okay, right. Okay, or you can use for your cellular phone. Okay, the following types of wireless media is infrared. So this is the frequency range. Okay, application we use for remote control. Okay, for wireless mouse, keyboard, and so on. Okay, with that, I believe it is the end of our lecture today. Okay, so if I have further resources, okay, I will post through the ulearn. Okay, as well, if I have any assessment, I will post to ulearn and I will inform through the WhatsApp group as well. Okay, okay, class. So I believe it is the end of our lecture today lah. Okay. Do you have anything to share before we end our session? Suhaili, Emilia, Abdullah, Nadira.
Sir,
Yes.
okay, boleh tak tanya?
Okay.
Kalau macam soalan-soalan exam kan,
Okay.
adakah dia something like yang example, 5 example yang Sir tunjukkan tadi?
Okay. Most of the time, it will more or less like the example being given lah, the structure, right? But there will be also further reading types of question lah. Maybe into something like application and so on. So therefore, you need to always keep up to date lah with the latest trend. Okay, tapi whenever you talk about calculation and so on, most probably we'll stick with the example format that been given lah. Okay.
Alright.
Any further question or anybody want to share anything? Everybody, shall we end our session?
Sure, sir.
Okay, and wait for me lah for announcement for the face-to-face session, right?
All right.
Okay.
Alright,
Okay.
sir.
Okay, so with that, I would like to thank you all for your time, and I would like you to have a very pleasant weekend. Okay, and from time to time, just keep track. Maybe I will post a quiz and whatsoever, even even not in our time, but you can do in very short time, maybe half an hour. Okay, to attempt the quiz and so on, online quiz. Okay, with that, I would like to thank you all for the time. Okay. Okay, thank you. Assalamualaikum.
Alright, thank you, sir.
Thank you, sir.
Thank you, sir.